Hello everyone, welcome to the TheCloudCareers YouTube channel. In this session, I'm going to talk one of my most favorite and interesting topic and one of the most used option in AWS, which is EFS. EFS stands for Elastic File Share. Before I say anything about, I would like to give a quick scenario on what if you have a file that is residing on one server that needs to be read or write by multiple servers in the others in your application. That means you're having multiple applications that are running on multiple servers, and all of them want to read or all of them want to write on a same file or a set of files. How that's possible? What I mean, let's go back. For example, you're having an EC2 instance. For instance, take it as a Linux machine. And by default, it will be attached with one volume, which is a EBS based volume. EBS stands for Elastic Block Storage. Understand this word block. When I say block, that means it is a block type of storage. That also means in storage, there are multiple varieties of storages, which we are going to talk very soon. But whatever the disk that by default Amazon offers is EBS volume, which is also called as a block level storage. The advantage with block level storage is it's a raw data. That means the operating system that is on the top of the server is responsible for the entire file ownership. That also means if you plan, okay, whatever the data that my applications that are running on different servers want to read or write from this disk, I'll create multiple servers and I'll be reading or writing it. No, that's not possible. Let me try to show you that. In conventional infrastructure, this is how it works. One volume per server. If you're having three servers, each and every server will have one volume. That also means you can have 2 to 3 volumes per server. Okay, but each and every volume can only be owned by one particular server due to the block level ownership constraints. If you create one more disk like this also, it has to be owned by one operating system, one server. That means whatever the files you read or whatever the files that you write can only be read or written only by this particular server one, not two and three, not two and three. If you fall into a situation where you are having multiple applications that wants to read the data from a specific file and want to write the data to the specific file, you can think I'll create one specific volume for my application. And if this is a situation where you want to create a disk called as app data, and where you want to mount this single particular disk, which is also called as EBS volume, to all three disks, all three servers, then this either the server one or server two or server three can read the files, and server two or server three can write the files that are read by it. That means all of them can have a common storage. If this is the expectation, but with the type of storage that we use, EBS, elastic block storage, that's not possible. Okay, because block level storage is not intended to do the purpose. But what if you land into a situation that you want to deal that? Okay, so that's where today's session is about. And if you want to mount like this, it's not possible, and one volume cannot be mounted on multiple servers for read and write. Then what is the solution? So what is the solution if I want to file shares on multiple servers that can read and write the files? Like my server one should be able to read and my server two should be able to write on the same file. How can we do that? So you need to use another type of storage, and that storage type is a file share. Okay. So in Amazon, it offers as a service, as a managed service called as Elastic File Share. The beauty of the Elastic File Share is it offers one of the best durability and scalability. And at the same time, you don't have to pay by saying, I would like to reserve 100 GB and you have to pay for the 100 GB. No. In EBS volumes, if you take 100 GB, whether you use or not, you need to pay for the 100 GB. Okay. For example, if you have reserved 100 GB disk, okay, either you use it or not, you need to pay. That means whenever you are having a predicted workload, whenever you know that the data that is going to be stored is this much, you block it and you pay for it. Whether you use the disk to the 100% or not, you pay for the 100%. But EFS, it's not like that. So the solution is Elastic File Share. Okay, so it is also the native form of it is network file share. You over the network, you can share the files. Okay, typically in the organizations, okay, you have a common file where all the common data is going to be stored, the fun data or any other data. But whenever your application wants to enter into such situation, the easiest thing to do is EFS. EFS is one of the nice option, one of the very reliable service in AWS, and it's serverless. That means you're not responsible for the underlying infrastructure, not even the patching, and it's scalable up to petabytes. For example, if your application today is using 5 GB, you just pay for 5 GB, and tomorrow because of some huge business and your data grows to 2 TB, you're gonna pay for 2 TB. Okay, and it's gonna scale exponentially with 11 nines of durability and availability. That means it's almost never down, and it offers out of the box reliability. Okay, and it also offers some best billing mechanisms that's called as a storage classes mechanism, which we're going to talk later. But in this session, I would like to simulate a situation where, assuming that I have multiple applications, let's assume I'm having an application called as a payment that is running on this particular server, and I have another application that is running on my this, which is a dispatch. And let's assume that I also have another application called as ratings that is running on this server. Okay, all of them belongs to one e-commerce based application, and whatever the payments that are done needs to be okay, that information would be written on the top of this file share, and that file share information has to be read by this dispatch application, and then it has to do that some processing, and then once the processing is done, it has to update that information. Once there's some update happens on this particular file, this rating application has to write the data. That means one single file or multiple single files from a single point are being read or write multiple times. And if you want to achieve this, you need to have a NFS based solution, which is called as a network file share. The same network file share, which is a file share based storage, which is another type of storage. Okay, Amazon offers it as a managed service, and the managed service name is Elastic File Share. Okay, it's not system, it's Elastic File Share. How to do that? Let's go and try to do things in practical approach. Okay, so for the demonstration purpose, I have created a couple of servers, and the servers that I have created were okay, ratings and dispatch. These are the two Linux based applications. These are just two T3 micro Linux based machines that I have created just to save some during the demo. And assume that you have running an application called as ratings on the top of it, and another server that is having dispatch application on the top of it. Okay, now I also signed in. Here I have signed in as a root user. I'm running ratings application on the left side of my window, and dispatch, which is a different application, which is running on the different server. Just to prove both of them are different IP addresses, and the IP address office is this, and this is a different IP address. Okay, just to prove that both of them are two different servers. Okay, fine. Now, what I want to do is I would like to create an EFS Elastic File Share, and I'm gonna write some files in this server. I'm gonna create some files on this server, and those files you should be able to read or write on these servers. How can you do that? How can you achieve multi-read or write from a single point? Okay, single file share. Okay, if it is an on-prem based solution, you'll buy some NFS based solution, which stands for network file share, and you are responsible for the underlying storage, NFS based software, administrator who maintains that NFS. But if you use cloud, you don't have to worry about the underlying infrastructure, underlying software, and you don't have to buy the file share based storage as well here. How much ever you use, it exponentially scales and you'll be billed based on your usage. Okay, and EFS in AWS is very, very quick, very, very simple, and it offers out of the box integrations with the internal services. Without any delay, I'll go to EFS. I'll go to the service called as EFS, which is an Elastic File Share in AWS. And then, okay, which is a managed file storage for EC2. Select this. Okay, so it is a scalable Elastic Cloud Native NFS file system. Okay, I already said NFS is a technology, network file share. Using this, you can share a file system to multiple Linux-based systems. Okay, but using this technology, Amazon has built a managed service called as Elastic File System, ensuring you don't have to build your own NFS system. And the beauty of it is, okay, and the beauty of it is, if your infrastructure is on cloud, it's not like whatever the mount point that you created is only applicable for that particular infrastructure. For example, this is your on-prem and this is your cloud. This is your on-prem. On-prem is nothing but your data center, assuming, and this is your on-prem. Okay, so this is your on-prem. And this is your data center. And this is your cloud. If you create a file share here, EFS, not just the machines that are running within the cloud can access, even the infrastructure that is available on the top of the on-prem can also access it. Okay, so earlier that option was not there. Amazon has introduced few years back. Okay, so if you create a file share on EFS, okay, typically typically if yours is a serious business, you have your infrastructure both on cloud and on-prem. What if you have a serious workloads that are running on on-prem that also needs the data that is released here on this elastic file share? EFS offers the integration with on-prem as well. But in this demo, I'm not going to demonstrate that, but I would like to create a file share and I would like to show you how can you map it against the service in your infrastructure and how can you parallelly read and write. Okay, let me show you. Okay, so I have created a couple of servers. All I do is I create an elastic file share, and the name of the file share I would like to do is, let's say it's a sales application. Okay, sales data. All right, this is the name of the file share that I'm creating, and you need to mention in which network that you want to create. Right now I have two networks. In your case, if yours is a brand new account, just create it in the default network. Okay, customize, don't just create it, go to customize. I would like to walk you through the rest of the options as well. And again, EFS is both regional and zonal. Okay, so if you create it in a zonal, that means only one particular zone, whatever the data that is being stored on the top of the file share will only be available on this particular zone. That means if you lose this zone, because if Amazon experiences a network outage or outage on this particular zone, all the applications that are using this particular zone will be impacted. So it's not at all recommended to keep one. So in any production based workload, a minimum of 3 zones, okay, at minimum 3 replicas of data has to be replicated across the zones. It doesn't mean if you selected your data location as East 1A, it doesn't mean if your instances are in 1B, 1C, 1D, they cannot mount it. No, it's not like that. This is only where the data is saving. The data is saving on East 1A. That also means servers on East 1A or East 1B or East 1C can access. Okay, a lot of people will think that if you create it in East 1A, only the machines that are on East 1A can access. That is not true. Okay, in any serious business, you need to create a minimum 3 copies. Okay, and I selected regional and I also enabled the automatic backups. Obviously, if it is a file share, multiple systems will read and write. Backups are very important. And this is a lifecycle management policy. Objects that are frequently accessed would be in the standard class. And if any of the files that are being saved on the file share that are not being used will automatically move to some storage class with a lesser billing. Okay, so this is called as a lifecycle policies. So if the data is being frequently accessed, it has to be in a storage with higher IOPS, input output per second. If not, try to move it to an archival class with which costs you lesser for the storage utilization. And by default in Amazon, data that you save on the top of this particular service is encrypted at rest. That means whatever you store on the disk will be encrypted by default. But if you want to go through your own disk or your own keys, which I have demonstrated in the previous session, you can also use this. Okay, that means using your keys, it's going to encrypt everything. But I do not want to go through this. I just want to go with Amazon based encryption. Next, throughput. Throughput is like how many inputs and outputs per second it can offer. It's basically a metric for performance. Okay, if you are having higher CPU, higher memory, and if the disk is not offering greater IOPS, that means infrastructure, your compute cannot read and write quick from the disk. Okay, for all the production based workloads, go with enhance. It offers better performance. Okay, and next, go with the next. I selected next. Now I click next, and the moment it went next, and here, since I have selected as a regional, all the networks, all the subnets and all the availability zones that are there had the default subnets that are added. Okay, that means your data will be replicated across 6 different zones. I mean, for the demo purpose, it's fine. But if it is a serious business, we keep a minimum of 3 copies. If you store 1 GB, the data will be replicated across 6 zones. That means you need to pay for 6 GB. Ensure you select the zones based on the need. Now select next, and then you can mention prevent root access by default. This ensures that no one can access the root directory within the or the root values within the EFS. Okay, you can also mention enforce read only. That means everyone can just read the files. Okay, for example, you have some serious data, but you want all your users just to read. You can also enable this. Okay, prevent anonymous access. So this ensures that no one without authentication, I mean, all the data that a person uses or a user uses will be monitored. And enforce transit, in transit encryption for all the clients. That means when someone reads the data from source to destination or from destination to source, the data during the flight will also be encrypted, okay, which I don't want to do at this point of time. Enable, then scroll down all the way down, just say create. It's very quick. Okay, in less than a minute, it's going to create the entire disk. Okay, so it's very, very quick. And if you see, the file share is available. And if you select this sales hyphen data, and you can see, so this is one of the nice feature that I like. Okay, so it also shows you what is the overall utilization of the data. Okay, out of this size in the standard, for example, if you're having 100 GB of data, uh, out of 100 GB of data, if 70% of the data is not being used in last 30 days, it moves to the archival class automatically, 30 days or 90 days. And it also show you out of this 100 GB data, which of the data is frequently used and which of the data is not frequently used, which type of data is, which amount of data is in the standard, which amount of data is in the archival. This is one of the nice feature that I like in Amazon. Okay, their insights are quite insightful. Okay, now I can show you, scroll down, go to the tags, file system policy, access points. Okay, 1 minute, network, done. I think my file share is available. Okay, you can see the status looks available, and you can also see the state is available, and it clearly says it's reasonable. All right, so you can also see replication on override protection. Perfect. Okay, come here and select this. Now what I would like to do is I would like to attach this. How can I attach this? Okay, it's very simple. All you need to do is click the select option and copy this. And I would like to mount it on my server, and I would like to mount it on a directory called as sales. Okay, PWD. I'm inside the root directory. So I have a directory called as sales. I would like to mount the sales directory that I have created on my server. That means whatever the data that I want to see or I want to write on the top of that file share can be accessed from this. So I'm mounting it. Mounting is like placing, like you take a pen drive and put it into your computer. That's called mounting. Okay, so sales. All right. Now this particular mount point or the file share that you have created will be mounted on the top of it. Okay, ls-ltr. Now if you see a df-h, okay, display file system in a human readable format, you can see this particular root-sales is mounted on the top of it. Okay, now I'll go enter into it. Okay, now I'll also do the same thing. Okay, now what I do is I'll enter into sales, done. I'll create files, touch devops.txt, kh.txt, tf.txt, sales.txt. Okay, I have created how many files? 4 files. Okay, carefully. We are in the ratings machine. Okay, now on the dispatch machine also, I would like to mount the same. Okay, mkdir. I would like to create a directory called as sales, ls-ltr. You can see sales. Okay, ls-ltr sales. Now I would like to mount the same. Okay, I would like to say sales. Done. Now this is also mounted. You can also see df-h. It is mounted on root sales. Now, if you enter into the sales, you can see the data. Can you see this? Now, what I would like to do is I would like to write some content into it. Okay, echo today's sales is really good into sales.txt, and echo I would like to write one more file. Kh is also referred as Kubernetes. Okay, ls-ltr. Now you can see kh.txt. So the kh.txt file is updated in a different server, dispatch. Now if you come and try to read it, can you see this? That means you are reading and writing the data from a common mount point. Elastic file share or the network file share would be used whenever your application needs a common data, or you're having multiple components of an application that needs to read write data to a common point so that your entire application would be in sync. Okay, so not just here, even in Kubernetes, you can use EFS based share. Okay, so this is how using EFS with the technology of NFS, you can mount between multiple servers. Okay, now coming back, we talked about storage types. Why block level storage? Why the disk that is offered as a block level storage cannot be mounted on multiple servers? If they offer like that, the game is over, right? Why these many types of storages? It's as per the design. The block level storage is like a raw storage. Okay, raw storage without intelligence. That means it is purely owned by an operating system, and the operating system is the owner. It can only have one owner. Okay. Another type of storage is blob storage or the container level storage or the file storage. That means just like your Google Drive or S3 buckets. Okay, it offers file level storage, like where you can store your images, videos, anything, any binary data, anything. Okay, if you want to install, but you can ask me, even in the block level storage, I can store it. But for example, I'll ask you a question. If you want to install an operating system or if you want to install a VLC player, the storage should be a block level storage. Okay. But if you say I want to install a VLC player or operating system on a Google Drive, which is a blob storage, it will not work because operating system has to be installed on the block level storage or software has to be installed on the block level storage. Block level storage functionally has to be owned by an operating system. Okay, so that's the difference between block level storage and blob level storage. And another type of storage is file share, NFS. Okay, network file share. This is altogether a different storage technology. Using this technology, you can create a file share that can be accessed across multiple machines with ease. Okay, so in on-prem based technologies, you need to have NetApp based technology, okay, which can help you with the NFS. But if you are on cloud, you don't have to go through that. Okay, so Amazon does everything for you. Okay, that's about it. But I'll ask you another question before we wrap today's session. Everything sounds easy, but there are some complications as well. I'll ask you the complications. Okay, what's next? Okay, it's just a very straightforward thing, right? What if here any server is accessing, right? What if I want to restrict only specific VMs should be able to mount? So I just got to know the command, I ran the command, it mounted, right? But what if I have 500 machines and out of 500 machines, I only want to give access to 20 machines, not everyone? How can you do that? Okay, so what if I want to restrict only to specific VMs should be able to mount? That also means, okay, that also means you are having multiple servers, right? Okay, so I do not want this file share to be accessed by my third server. Okay, this is server 1 and this is server 1 and this is server 2 and this is server 3. I do not want my server 2 to be able to access. Okay, my server 2 should not be authorized. How can I do that? Okay, now another limitation, not limitation. Okay, what is the if you have that use case, how can you do that? Okay, that's my question to you. And next important thing, what will happen? You know what? Whatever you mounted here, DF5 and H, all of them will be gone. Not all of them. Whatever you as a human user has mounted manually, all of them will be unmounted. That means when you restart the machine, these mount points won't be there. What will happen to the mount points if the server goes for a restart? Okay, whatever the mount points that you have mounted manually, everything will be gone. That means if your application is dependent on the top of the sales data, your application will fail. If you want to know how to restrict only specific VMs should be able to mount, or how can you ensure if a server goes for a restart still, just like how your operating system and services are coming up, I also want my mount points to be coming up automatically. If you're interested to know that, I'm expecting at least 5 to 10 comments in the comment section saying that I want to know how to restrict. If I get 5 comments, I'm going to release a next video saying that how can you restrict only specific set of VMs can access, and how can you ensure that whenever the server goes for a restart, it comes up automatically. Okay, that will be the next video. If I get five comments, that will be the next video. If you like the content and if you feel that the content is interesting, please like the video and subscribe to the channel. Thank you. Signing off.